Hello, I'm Ilan from Group B. Today I'm going to talk our project description. This project is applying the Pascal's principle, which is the value of pressure is the same as the pressure value out. The open box bed of the truck will incline when the syringe is pushed. As you can see the picture down there, the first syringe is pushed to its maximum capacity and the second syringe is pushed outward to the maximum capacity that made the box bed to incline to its maximum angle. The next part is the theory of our project. The theory behind this is basically a liquid cannot be compressed and the pressure acting on the liquid will be transmitted throughout the liquid. As what Pascal's principle states, that the pressure exerted on a confined fluid is transmitted equally in all directions. The rest of our presentation will be continued by Joel.
Hi, my name is Joel Raj and my matrix number is 15 DKM 21F1029. So, I'm here to talk about the material and costs. As for the costs, all the total materials costs Rm 16 ringgit 68 cents. So from this, we can approve that our project is cost effective and easy to build.
For the objective, the main objective is our project can lift an object with a mass of 100 gram using Pascal's principle. Secondly, the project is eco-friendly as it's basically constructed using biodegradable material and it also costs less to manufacture. As you can see the picture below, we've used some biodegradable materials and the end product was basically complete project made out of cardboard and popsicle sticks, that is 100% biodegradable.
As now for the result and discussion part. Our project has been successfully carried out and it can lift about 100 grams of weight. For the calculation part, we used two syringes, syringe A and syringe B. Syringe A acts as pump while syringe B represents as actuator. The force used to press syringe A is 5 Newton while the area of both syringes are 0.000178 meter square. Okay, syringe A and syringe B. As I mentioned before, the area of both syringes is the same. So for syringe A, we used 5 Newton force and can be labeled as F1, and for syringe B can be labeled as F2, which is X. We are going to find it now. So we used the formula pressure at X, which means A, equals to pressure at Y, which means syringe B. So F1 over A1 equals to F2 over A2. F represents force and A represents area. So 5 over 0.001768 equals to F2 over 0.000178. So we must find the F2 here and the answer is 5 Newton.
As for impact, the impact of Pascal's principle is very useful to our very life and it helped us to do work more easily and efficiently, such as power steering, transmission, brake, excavator, lift and many more. And for the conclusion, my friend Joel continue it. That's all from me now. Thank you.
As for the credits, I would like to mention and thank Inche Mizan, our engineering science lecturer, who helped us in guiding and correcting our mistakes throughout this mini project. I would like to also thank my teammates Alif and Haris, who made this project successfully. They spent a lot of time to build this project with using their own money. I would like to also thank Ilan, my teammate, who made slideshows and big explanations on this mini project.